So last class we discussed about the linear data structure array. So this class we will be learning one more linear data structure called stack. So what is the linear data structure means? So already we are familiar with what is the linear data structure means. A data structure in which the elements are stored in consecutive memory locations, that is using adjacency relationship. Such data structures are called linear data structures. So one is arrays, already we have discussed, and we have one more is called stack. So stack is another data structure in which the elements are stored using adjacency relationship. I think vocabulary meaning of stack also you are familiar with. Something arrangement. So we keep one above the other. That is a stack of files, stack of books, stack of plates. This is how we come across in real life as well. So whenever we learn computer science, don't think this real time what we are using is different and there is something else is associated with the computers. Never think like that, because computer always used to assist humans. So therefore, whatever the terms, whatever we are studying in our real life, the same concept would also be implied, or it will be used in computer as well. So therefore, it is important to learn the vocabulary meaning of each topic heading and then understand physically how this component works. Then we'll come back to the topic with respect to computers. So now stack, let us be familiar with the word stack. I think everyone is familiar with what is a stack of books. Might have seen everywhere. You can see when you enter the college, there also you have seen stack of books in the rack arranged. And also you go to cafeteria or anything, a restaurant, there is also a plates will keep one above the other. That is a stack of plates, stack of books, and depending on requirements we have a different stack. That is, even a carrier which was earlier it has been used, so where we keep many boxes and it is locked, that's also one above the other. So there is only one end where you can remove and insert. So that is what we called as a stack. So what is the stack in computers? So how do you define stack in computers? So normally computers can hold only data. So it may be characters or it may be numbers, whatever it is. So those things should be arranged in the form of stack. That is, you think it may be a numbers we have arranged, or it may be characters we arrange one above the other. In general, any type of digital data could be organized one above the other. That is what we called as a stack. So what is stack means? We can define stack is a ordered collection of data item such that the insertion and deletion takes place at the same end. That is called top end. The opposite of top end is called base. So now we have a stack. Stack is an ordered collection of data items. So where insertion and deletion takes place at the same end, that is called as a stack. So where we insert and we remove, that end is called as a top end. So opposite of top end, that is other end, it is called base. Definitely it is below, so it's a base, and above this we organize one above the other. This is the one which is recently inserted, and this is the one which has to be popped, that is to be removed. That's why I said insertion of new item into the stack and removal of existing item from the stack is always takes place at the same end. So that's why it is called as LIFO, that is last in, first out. The last inserted element is the one to be removed first, last in, first out. I think already I have given many examples where you come across with the stack. So when you organize anything which one above the other, so where only one end is available for insertion and deletion operation, that is called as a stack. And also, what is the use of such things? Maybe when you organize like this, what is the use means? Once you complete this topic or this stack, then I'll tell you what are the important things where we use stacks and what is the necessity of these stacks. So it's very important. It plays a very important role in computer science. The stack is one of the most important data structures. So now you can imagine what is stack means, how it may look like means. You can think the stack looks like this. So this is, you can call this a stack. So where we organize like this. Some element 3, 4, 5, and this is called top end, and this is called base end. So this is how where we keep insert and we remove. So this is 3. So you want to insert one more. So this is top here, it is 6, and top comes here. So this is how the stack looks like. So this is how we are going to explain how stack can be represented. Stack means it is an ordered collection of data item such that insertion and deletion takes place at the same end. This is the only one end. So here you cannot insert and delete. So there's only one end, insertion and also removal takes place at the same end. So this is called as a top end. The other end, this one is called as a base. So this is a stack. So stack is ordered collection of data item where insertion of a new item and removal of existing item will always takes place at the same end. So now let us think how they are going to represent. And also one more word you should be familiar with this is already I have told LIFO. It follows the principle of LIFO, that is last in, first out. Now last in was 6 and this is the first to be removed. So that is why it is also known as, or it follows the concept of last in, first out. So LIFO data structure. Sometimes they ask expansion of LIFO or give example of LIFO data structure, that is a stack. Or what is a stack? Maybe they can also ask one mark question. So this is how stack looks like. So now how do you represent stack in a memory? So there is two methods or two way of creating stacks. So one is called static representation of stack, that is we use arrays. So another is called using dynamic representation of stack using linked list. So we'll learn linked list, so that is at the end of this chapter, but now we go with the array. So already we have this. So it's a static means fixed. Already last class we have understood disadvantages of stack where we have fixed size. So in real time sometimes we can use a stack for a limited. So or sometimes you can go for unlimited, that's a capacity, you can go for linked list. So there are dynamic methods. So dynamic means as and when it is necessary, a memory is allocated and during the execution. But in a static means, so before we compile, before we execute, so memory has to be defined. And this is the amount of memory and that cannot be changed. So if you have used 10 means, so the stack can accommodate maximum 10 elements. We cannot include more than 10. So that is a static. It's always fixed. We go to another means a dynamic. It doesn't make, there is no limitation. As and when required, a dynamic memory is allocated and it is used. That's a simple. That's also we will discuss in the later classes. So now let us learn about static representation using arrays. So already we have understood arrays. So array is a linear data structure, and also I have told the advantages and applications of arrays. So whenever array we have discussed, so I always told, so where is the application, where do we use arrays means, arrays are used to implement stack. So if you closely notice this example, so diagram. So there you can think this is nothing but an array, one dimension array where you have subscript 0, 1, 2, 3. Or you can write this, if this is what we are familiar with. So this is, so you easily understand this is like 3, 4, 5, 6. So array in the form of column, that is one dimension array. Or it could also be written like this, one and the same. So this is the top. So this top here in a stacks works like subscript when you implement using static allocation. Now it is nothing but a subscript. So if it is stack A means, so A of top means 6, like that. That also you can use. We'll learn that later on. So this is something about the stack, how you represent. So whenever we talk about static means, it's always as a maximum size. So normally we are declaring let A be an array with n elements. Similarly, you can also define a stack. Array name is a stack and also it has a max stack. So any word you can use, or you can use n also. That is the size of the stack. So sometimes we use a max stk. That is just a name given. So that can be n also, or because they choose descriptive name. That's all. There is not a difference. Should we use n or should I use, because it's a stack, so I should use max stack like max stk. So it is just a name given. So it can be n, but it is to choose as a descriptive. So we can use, max stack, or still you can use n as well. So that is something about the stack size. And whenever we try to insert an element into the stack, that is the max stack will decide, is there any space to accommodate the new element. So if it is full means we cannot insert an element. Similarly, how do you know the stack is empty means we use a null. So null pointer that will give that the stack right now is empty. So this is we are using when you perform insertion and deletion operation with the stack. So now we have understood stack is a linear data structures. So whenever we talk about data structures, so there is a necessity of the operations. Already we have come across traversing, searching, sorting, insertion, deletion, merging. So these are the operation which could be performed with the linear data structure. So here stack is also a linear data structures, hence these operation could also be performed. But here we use the two important operations, that is normally it's nothing but important means whenever we use a stack, the most commonly performed operation is called insertion. So another operation is called deletion. So they are named with the two word, that is called push. We do not call it as a insertion, we call it as a push. Another is we have a pop, that is a deletion. So we learn this. So because we are pushing into the stack, that's why they use the word push. And removing, popping off from the top element, it is called pop operation. It's nothing but linear data structure. It is just an operation of insertion. Another is a deletion from an array. But they are used with respect to the stack. So therefore, I use the stack push and then I use pop. And then also we have other functions like stack. So this is used to find the stack. So whenever you want to create a stack, this is like function. So this is not just it's a function like I may use. So whenever we do this program practical, so there we use. So that is to create a stack function. This function creates a stack, that's all. And then this push will insert an item into the stack. So similarly, pop deletes an item from the stack. And also we have a size, so that identifies the number of elements in the stack. And seek will give you, moves the pointer to the top elements. So these are the what we call operations or functions, which are most important operation is called push and pop. So normally what happens, push means, so we have to provide an item. So whenever we perform insertion means, so we are supplying some external item. Like in this example, we can see a 6 has been inserted. So remembering it was only 5, then I inserted 6. So that becomes an item. So where you are inserting an element into the stack. So item becomes a part of this. So whenever we talk about push, we'll discuss next push algorithm and then pop algorithm. So this is the operations which can be performed with a stack. The most important are push and pop. So we learn about what is push algorithm and we'll also learn about pop algorithm. So next, describe. You can take the textbook and write down this heading. I'll read this so that you can write easily. Stack is the array that contains n elements. That is the size of the stack. And top is the pointer pointing to the topmost element of the array. And item is the element to be inserted. This procedure insert item into the stack. So normally when we perform stack, that's a push operation on stack. So we have to follow these steps. We'll write this algorithm I am going to write now. So I'll rub all these things. So let me take this push now. Important thing, push algorithm. So already I have discussed let A be an array. Now I'll write an array with like stack be an array with n elements like this. So far we are writing like array in the form of rows. Now let me write array in the form of column. And this is, you can name it as a stack. So instead of writing, so this whole thing is a stack array and it has a n elements, capital N elements. So what is a push algorithm? You may write like this. To perform push operation on stack, so we need a stack like this array, we have to supply. It's a function means it takes these arguments. Another is what do we need? We need a size optional and we need the top pointer and also you need the last one is the item to be inserted. Parameter you can change anyway, no problem. So now we can define let stack be an array with n elements, that is capital N elements, and item is the element to be inserted into the stack. So this procedure, what I am going to write, will be inserting an item this into the stack. The name is stack array. So whenever we perform the stack operation, that is push operations and stack, the first is to check is there a free space or not. So how do you say that the stack is full means, as we know that, so if you define array 5 elements means, so there are n means n minus 1 will be the subscript, that is the last position, that is the upper bound. So if it is a lower bound and this will be the upper bound somewhere here. So that upper bound is n minus 1. So if top pointer is pointing to n minus 1 means the stack is already full. So I cannot perform any operation. Otherwise, we have to insert the first thing. So whenever we perform a push operation on stack, the first is to check the stack is free or not. So how do you check means look at the top pointer. So if the top pointer is pointing to the upper bound, that is n minus 1 because I have took n as a number of elements in the stack. So therefore, so if I write, let me start as usual algorithm. Step 1, start. Step 2, now let me check. So first is if top pointer is equal to n minus 1. So what is this condition says? The top is pointing to upper bound, that is this array is full. So therefore, we cannot perform the push operation. So therefore, you can give a message saying that the stack, present stack, the stack is full. The stack is full so that you can insert an element. So now what we can do otherwise else. So it is not full, top is not pointing to the upper bound, so it may be any number. So therefore what we do means then we insert. Before we insert, what we do means we increase. Suppose like this. Let us take some examples. So right now we have some element here, top is already pointing. So now it is 0 subscript, so it is 1, 2, 3, 4, 5. So whenever we insertion operation is performed, let us take this. Right now we have some element. It is not full, something like this. Let us take like this example. So now it is not n minus 1, it is something like it is pointing. Yes, you can see the free space available. So what I can do now, so just to perform insertion operation, first the top has to be moved because I want this subscript, that position. So therefore, first is, if it is not full, increase top equals top plus 1. So wherever top pointer was, it is, and it is moved to the next position, that is, it is goes to the next adjacent memory where there is a free space because it is not full. So then this is the most important. First we have to increase the pointer, that is indirectly move this pointer here. So where right now it is vacant, so there you are trying to insert a new item. There you copy, that is stack of, that is array we are writing A of. So now it is stack. So stack of top. So after insertion, after increasing, so now you are pointing to this vacant space. So there we have to add new item, that is item. So item, suppose if it is a 8, means the 8 will be copied by this procedure. So what we have to do when you do push operation is, first we have to look the stack is full or not. So if it is full, the stack is empty, we can't do anything. Go to, you can use a go to statement at the end, or other words you can use a if else also. So you can use, let me use, it is a programming, so generally you can use go to statement. So you can use go to here, go to step number, if you take 3, 4, then we use 5. You can use this for if and. So if stack is full, display the message, that is stack is full, and go to step number 5, sorry. So stop, it is 5. So algorithm ends. Otherwise, so it goes to next. Increase the top pointer because there is a vacant space. So then you add the new element at that place, that is stack of top, we are adding the new element. So this is an important algorithm. Usually, 2 marks, sometimes 3 marks, they may going to ask you in the exam. So very important, not only for examination point of view, but when you go for higher studies as well. So this stack is going to be very important. This push algorithm is the most important. Whenever we talk about stack means this push and pop are the most important functions, you can call that as algorithms. That is, you will be learning in the programming. So we are going to write these stack programs. So anyhow, I think you have understood clearly, very simple. The stack, in order to push item into the stack, you need an item, you need a stack, you need the size, optional, and then also we use the top pointer. The first task is to insert an element into the stack, means first we have to check the stack has a space or not. How do you identify? Or in other words, first you check the stack is full or not. If it is full, we cannot insert. That's why we check if top equals n minus 1, the stack is full, so hence we cannot insert. Otherwise, increase the pointer so that it shifts to the next memory in an array. So there you add the new element item, and that's all. So this is a simple algorithm where we are going to insert an element into the stack. So now we go for another is the what we call the pop algorithm. So this is a push. So one more we have algorithm that is called pop. So what is pop means? It's a process of removing So, we are removing the topmost element from the stack. So, that is called pop. We define same, let stack be an array with n elements, and this top is the pointer pointing the topmost element. This algorithm deletes the topmost elements and is copied to the variable item. So, we write the pop algorithm. So, we can take like this. The algorithm almost it needs all the parameters. However, if you don't want, you can do not use size, because we are not comparing. So, stack is no problem, even top item is enough. So, now let us learn how to perform now is the pop deletion operation. How do you remove an existing element from the stack? So, first what we have to check here means, whenever we try to insert an element into the stack, first we have to check stack is full or not. If it is full, I cannot insert. So, whenever we perform deletion means, first we have to make sure that is it empty. So, there is no meaning to remove an element which is already empty. So, this is that's a natural phenomenon. That's how we do. We do not remove empty. So, it's empty. We cannot find. But how do you confirm? This example you can see there are some element I can delete. But sometimes after deleting all the elements, stack may be empty. So, when it is empty, so I cannot perform this operation pop. The pop can be performed when stack has some elements. If stack do not has element means, so we cannot perform the pop operation. Let us take a algorithm. Now, how do you check the stack is empty? It's very simple. Because everything is operated with array name stack with the help of top. Top is like a subscript. So, if it's a positive number, like greater than or equal to 0 means, so it is pointing to some element, some place like 0, 1, 2, 3. Other than this means, definitely it is not pointing to an array. That's why we use, if algorithmic, we use a top equals null. So, if it is null means it is not pointing to any of the position of an array. So, therefore, now you can say top is empty. That is, top is not pointing to any means does not exist top. So, obviously, there are no more element in the stack. So, then we cannot perform deletion operation. Then you can give output error message saying that. So, it's a message you can give. So, it is when top is null means the stack is empty. The stack is empty. So, next we cannot do anything. So, go to same step number, we will write what is the step number. So, otherwise, yes. Otherwise means this example. So, there exists an element. So, remove first. How do you remove means? You take item, some variable name. You are copying item from the stack. So, what is the topmost element? 8. How do you get this 8 means? It is array name stack of subscript 3, that is top. Stack of 3 is 8, that is we write stack of 3 means here it is top. So, this example stack of 3 is 8 is copied to item. So, after this, so now what happens? The next topmost element is, so this is over. So, where is top now? Top is pointing to empty. So, therefore, the top has to be decreased, that is it has to be, now it is should come to this element. This is the element to be deleted next. So, where is this position? 3, where the top has to be moved is at 2. So, 3 to 2 means minus 1. So, what the top having value is right now 3. So, top minus 1. So, 3 minus 1, 2. So, now the top value is being changed from 3 to 2. So, next step is stop. So, this is step number 5. So, this is the what we call as a pop algorithm. The process of adding new element into the stack and is called push The process of removing the topmost element from the stack is called pop. So this is, I think you have understood how the push operation. So this is practical program we have to execute in the lab. So that we'll do in the lab. I think now you have understood how the push operation is performed with the stack. Similarly, pop operation is performed with the stack. So next we learn the applications of stack. So just I'll give you an idea. At the beginning I have said why we need this kind of organization, insertion, deletion, something. This is one of the most important data structure used by the system software like compiler and the web browsers. Many places we use the stack, language processing, the compiler, how expression is evaluated, and playing Tower of Hanai game. Whenever we want to do backtracking, and recursion is also implemented using stacks. Whenever we perform recursion and converting from decimal to binary, there are many applications of stack. So that comes. Maybe you have seen. So when you navigate from one web page to another page, you keep clicking next, something. So and also there is a back option. So when you press back, it comes to the previous page. Again you press, it comes to the previous page. When again it comes to the previous page. That's how the stack is used. This is the first page, this is the second page, this is the third page. Now you have to come back, you can use back, so it comes to the previous page, back, previous page. So that is, when we just think of stack, it's of no use. But when you think this practically, where stacks are being used. And also one of the most common thing is, so whenever we use some documents, editing, any type of editing you do, most of them. So there what we do means definitely we are going to make mistakes. You wanted to type something, you type something else, or you are drawing something, you did something else. So then what we have to do means that has to be removed. So there we use a commonly used button is undo mechanism, Control Z, most of you are familiar with. So that Control Z, that is what we are using. Undo is also done by, or is the background supported by the stack. So that's why the stack size decides how many times you can press. The more the number of the stack's elements or entry in the stack, those number of undo you can do. Normally when you go for undo mechanism, maximum it goes to 3 to 5. So 5 undo you can do. After that you cannot do it. So that is where you can use, and also you can use in a recursion, and also used in a backtracking. So I think you might have familiar with the maze game. So where we have a, so maze game, you are familiar. So we have to move from one, we have to make searching of, tracking here and there. And once we reach the dead end, so there again we have to come back. That is a backtrack. So we have to go to the previous. So where is that previous? That is true. So whenever you travel, go like this, keeping the previous addresses. And whenever we have to come back, the stack helps to backtrack. So whenever we use it with the robots also you can use, and depends. So whenever I want to go like this and I have to come back again, the same sequence, that could be data structure where you can keep those changes. It need not be in games also they can use. It is left to you, how you, whenever develop software and you may come across. So I want this previous sequences, auto replay you might have seen, or something, many places you need it. So there also you can use the stack. And also we have a Tower of Hanai problems where we have 3 plates, all different sizes, and they have to be shifted from one pole to another pole. So that is also used by the stack. That's one of the most important. When you go for engineering or higher studies, you are going to develop the software for that one. That is, you are developing a simple program with the graphics and all, you can do it. That is the Tower of Hanai problems. So we have 3 disks where we have 3 rods. So that has to be shifted, this different sizes. You can imagine this is Tower of Hanai, maybe looks like this. So we have this like this, first plate, the second plate, and third plate. This is the disk we have. So similarly, we have to be shifted to this in the same order. So I have to keep like this. So how you do means, so that is, we have to use this one. First I'll keep here, then I'll keep this one, then I'll keep this one. So take this one and this. So this, how you do, there is a stack. So this, and also recursion, and also many applications, expressions, we have infix to postfix. When you write a plus b, and we have learning that algorithms also there. We'll continue with the, that we do in the next class. Quick sort, and we have many applications. So all they use the stack, decimal to binary. I think you are familiar with the decimal to binary means. Suppose we have something like 6 means, so this is you divide 2 3s are 6, remainder is 0, push into the stack. Next 2 1s are 2. What's the remainder? 1. Push into the stack. So again 1, push into the stack. Then pop 1 by 1. Remove 1, then 0. So this is 6 and this is binary equivalent. So that is we involve the stack. Stacks is being used. There are many applications you will be able to understand. So that is the need of, that's something about the stack and its applications. In exams they may be asking the application of stack. So that is the first one you can just summarize. Any 5 is important, remembering randomly also it's okay. So first one, so when this is most important, commonly used is reverse a word. So whenever you want to reverse something, some word means something, we have a ABC string and we have to reverse means, so just you pass into the, this is C, then B, then A, then pop from the stack. So it is A, then so if it's an array means like this. So first A will be pushed into the stack, then B is pushed into the stack, then C, then pop 1 by 1, that is C, B, A. So A, B, C, it is C, B, A. So this is how we can use stack also for reversing a word. The most common use of stack is to reverse a word, and the stacks are used for undo mechanism. Sometimes you might have come across, and also in back button in web browsers, there also you can use this stack application, and also it is used in backtracking, already I have explained, and also it is used in to solve tower of an eye problems. It is used to convert decimal to binary, and also it is used in recursions, and also it is used in syntax checking, like when we write an expression s is equal to a plus b semicolon. So then this statement is correct or not means just we push into the stack, and when we pop, so pair of flower brackets, some statements, language processing, the compiler may use syntax error to identify syntax errors. There also we use. The stack has got a lot of applications, and also it is used with the what we call the decimal to binary. So these are some applications of stack. So the most important is conversion of infix to postfix expression, and using one more is evaluation of postfix expression. So all these things we'll be learning in the next class. So that is, so for today we have learned what is stack and what are the operations we can perform with the stack, and most important algorithms, that is push and pop algorithms. And one more we have learned is the applications of stack and also the representation of stacks. So stacks can be represented in 2 ways. One is using the static representation, that is the array. So dynamic representation, I have not talked about dynamic representation because we have to learn about the dynamic memory allocation. So therefore, we'll continue that later when we learn dynamic memory allocation. Right now, array, which is familiar, I think you have understood. So we'll continue, right? The algorithms, definition, all important. So I think after arrays, so start with the notes, continue with the heading stack, then definition of stack, then LIFO, abbreviations you write, then the representation of stack, then you write the static and dynamic, and then we discuss the functions, operations on stack. Most important is push and pop. Then other functions we have the stack function creating, and then we have a size, then we have a isEmpty function to identify, returns boolean value true or false, and then the important algorithms, push and pop algorithms. Then you write any 5 applications of stacks. So that is something about the stack. So continue the same topic maybe in the next class.